my answer is 4. But what if I do absolute value of negative 4? Well, first you check, is negative 4 bigger than 0? No. Is negative 4 less than 0? Yes, so you plug it in here. What's negative negative 4? Positive 4. You see how it turns everything that's negative into positive? Everything that's positive, it leaves it alone. Okay, so now the derivative. The derivative of this should be a new piecewise function. Isn't it just 1 if we're to the right of 0? And negative 1 if we are to the left of 0. Would that be fair to say that? Bless you. And what about at 0? What's the derivative at 0? Doesn't exist. So notice I have greater than, less than. I don't have an equal on either one of these. What's that? You have a corner here. And so derivatives can't exist at corners, right? Another way you could think about it is if you graph the derivative, right? If you graph it, here's a derivative. If I graph it to the right of 0, it's 1. To the left of 0, it's negative 1. And so do you see there's a jump there, right? So the derivative can't exist. Okay, that's all great and fun, but that doesn't help us. That doesn't help us if we have something like this problem in the book, where it's the problem is the absolute value of 3t. It's the absolute value of 3t minus 4, g of t, right? And we're trying to find critical numbers here. So even though this is good, we need a formula for this. We need a formula for the derivative of this other than that piecewise function. So here it is. The derivative of the absolute value function of x is going to be x over the absolute value of x. There, box it up. Now let's see if you can make sense out of this, why this is true. We're not going to get into, I'm not going to prove it to you. We would have to use the limit definition to do it. I'm not going to do that. You took a lot of things on faith already, right, without me proving, so you're just going to have to take this one on faith. But let's just see that it works. What happens again if we're to the right? If we're to the right of 0, the derivative should be 1, right? So imagine taking a number and plugging a number to the right of 0 in. So give me a number. 4. 4 over the absolute value of 4. 1. Okay? Give me another number to the right of 0.
21.
21. 21 over the absolute value of 21. 1. Right? So as long as the number is positive, we're going to get 1. So as long as we're to the right of 0, we're going to get 1. But what happens when you go to the left of 0? Now let's take like negative 4, right? What happens if you put negative 4 over the absolute value of negative 4? You get negative 1 this time, right? Because the top's negative, but the bottom is going to turn it to positive. And wouldn't that happen for any number to the left? Yes? See how this works? So that's our definition. So with that in mind, okay? Is this okay?
So on the case of this question,
Wait, say again?
in the case of this question, how would we?
Yeah, how do we do it, right? How do we do it? So if we're given the function g of t equals absolute value of 3t minus 4, okay, the derivative of this should be, what's the derivative of the absolute value of this black cloth?
3t minus 4 over.
It's 3t minus, it's the black cloth over the absolute value of the black cloth. Chain rule, right? So it's the black cloth, which was 3t minus 4, over the absolute value of 3t minus 4, times now the derivative of what's inside. 3. Make sense? Chain rule on that new formula. All right. So now We want to find the critical numbers, right? Want to find the critical numbers, so we want to know where is that thing 0, where does it not exist? Well, there's a point that we have a problem, right? What's the point that we have a problem? Whatever makes this top 0 or the bottom 0, right? The same number makes the top and bottom 0. What number is it? 4/3, right? 4/3. So if we set the top to 0 or the bottom to 0, g prime equals 0 when t equals 4/3. And also g prime doesn't exist when t equals 4/3. So that's definitely going to be a critical number. So I come over here and I put 4/3 here. And I pick 2 test points. So let's pick a number. Let's pick a number to the left first. How about 0? I like 0. You like 0? Let's plug 0 into the derivative, right? So what happens if I plug 0 in here? -4, right? Over 4. So that's -1 times 3. So you get -3, right? Which means that our function is going down here. And then let's pick a number like, I don't know, 10, let's say. Rain coming? Really? I don't believe that shit. It'll probably be hail. Probably ruin all our roofs. Okay, 30. So positive on top, positive on bottom, +3. It's going to go up, right? We're done with the question, right? The question was the critical numbers. We only have one. I want to graph this. I just want you to see it. Let's do the absolute value, 3x minus 4. There's the graph. Do you see that we are 4/3? 4/3 is right here. Do you see that we are decreasing then increasing? And do you see that at that point 4/3 our derivative doesn't exist, right? Corner. Does that answer your question? Okay. We were going to have to go down that road eventually, so now is as good a time as any. Say again? Same way I just set the bottom equal to 0. See, we're asking what makes the bottom 0, right? When 3t minus 4 equals 0. So I set that equal to 0 and got 4/3. Yeah, top and bottom. Okay. Let me take a look at something here. We don't have many classes left. Today's the 14th? Okay. So here's what I'm going to do. We are going to do section 4.4 curve sketching right now, all right? And let me give you my feeling on this, all right? Right now you have all the tools you need in your toolbox to be able to take a function and draw a pretty damn good picture of it. If you put everything you've learned together in college algebra, pre-cal, calculus, we should be able to draw a pretty good picture of a function without a computer. Actually, a really good picture of a function. The problem with it is that we have computers now. So this section is somewhat obsolete. Before computers, before graphing utilities were readily available, this is the way math people figured out what functions look like, all right? So I'm not going to test you on sketching a function by hand, but I want you to see it, okay? I want you to see it, and you're welcome, because people hate doing this. It's a long, tedious thing. So I'm going to take a very nice example, like basic example. And let's see which one I want to do. Let's do this. I want us to sketch y equals x to the fourth minus 8x squared plus 8. Okay? Now, when I say sketch it, I mean we're going to use everything that we know, all right? Now, in your notes for this section, in the notes, I go through and I explain the steps for this. So I'm not going to write all the steps on the board because they're all in here, maybe. Where is it? Whoa. There it goes. These are the steps. Find the domain of the function. Find any x and y intercepts. Check for symmetry. Find any asymptotes. The steps 1 through 3 are all college algebra steps. Steps 4, 5, 6, 7 are all calculus steps. All right, so I'm going to start off by let's just see if we can find the x-intercepts of this function. All right, we're not doing any increase, decrease, any of that. Don't think about that yet. Just first thing, does this thing have any x-intercepts? Well, how do we find the x-intercepts of a function? Set it equal to 0, right? Now, by the way, this is not a function. It's not f of x, but let's just say it's f of x, okay? So our notation follows. All right, so I'm going to set this equal to 0. Now, I may or may not be able to solve this equation. I may or may not be able to. Yes?
Can you find the x-intercepts using a derivative?
No. Mm-mm. Well, not the way you think.
Not just by
There is no. You can't just take derivative and set it equal to 0. That won't give you x-intercepts. That'll give you the critical numbers, right, where you have humps and valleys and points and things like that. So, do we know how to solve this? It's not a quadratic. Does it factor? God, I wish it factored.
subtract by 8 and then part of group?
We could use a quadratic formula because it's a quadratic type, isn't it? But this looks like a pain in the ass, right? This looks like a pain in the ass. Yeah, so I'm going to put here, yeah, but no, okay? Yeah, but no. I mean, I don't feel like taking the 10 minutes it's going to take to find the x-intercepts of that. If it were something quick and easy, I would go get them, okay? I'm not going to. We could do it, not going to. How about y-intercepts?
Just plug 0 in.
Plug 0 into it, you get 8, right? So when you plug in 0, you get 8. Yay, we have 1 point on the graph. Yes. Okay. So I found the intercepts. The domain was everything, right? Domain is all real numbers. I should just put that here. Domain of this function is all real numbers. Okay, how about asymptotes? So does this have any vertical asymptotes? Is there anywhere where we get like division by 0? No, right? How about horizontal? Does this thing ever go, does it go somewhere as we go to the end? So I'm going to put here vertical asymptotes, none. Right? Because there's never division by 0. Vertical asymptotes, VA, is that all right? Horizontal asymptote, I'm asking what is the end behavior of this function? So what does this function do as I go out the left? What does it do as I go out the right? We can do that with calculus. What am I really asking for? The limit as it approaches negative infinity and infinity. So what is the limit as x approaches negative infinity of this function? So imagine, negative infinity. Imagine negative infinity to the 4th power, right? and then subtracting negative infinity to the second power. Isn't that infinity minus infinity? Which one wins? The fourth, right? Remember when I talked about how it dominates this one? So this is going to become really big and infinite. Plus 8 doesn't matter. So isn't that becoming infinitely big? So this is headed to infinity. That means if we draw it out to the left, it's going to go up, right? Now if we draw it to the right, what happens? Same thing. Because these are both, fourth power and second power, what happens out the left is the same as what happens out the right. Good?
What step are we in?
Well,
Step 3?
yeah, I stopped writing the steps. Okay, the first one was domain, sorry, and then the intercepts. So I have them written wrong.
Did we do the symmetry already?
Symmetry, no, I'm not doing symmetry. I'm not going to do symmetry at all. Again, that's really because we're just going to gloss over this section. I just want you to see me going through graphing it, and then we'll say, yeah, we'll just go type it into Desmos and be like, yeah, that's easier, right? All right, so this is basically the feel of what's happening. I have a y-intercept. I know both sides go up, all right? So now let's start doing the real calculus stuff. Let's find where this function's going up and down. Where does this function go up? Where does it go down? Let's find local max mins. All right, so I take the derivative, right? 4x cubed minus 16x. That's it, right? Set that equal to 0. Yes?
So we don't have any horizontal asymptotes.
No, we don't have asymptotes. This is me checking for them, and I'm saying there aren't any, but it is important to know that both sides go up. So this is not an asymptote, but it does tell me I'm headed to infinity. Yeah, good. Glad you are clarifying that. Okay, so I set this equal to 0. And that should be easy to solve, right? I can pull out a 4x. No, not a 4. Yeah, no, 4. Oh. Right, pull out a 4x from both of those. That's a difference of squares. Right? So 0, -2, and 2. 3 critical numbers.
I thought we used the second derivative to find those.
To find what?
To find those points.
So that's the I.
Oh, okay.
These are critical numbers, right? So I'm going to use these on a number line to figure out where my function is going up, down, right? Then we'll do the second derivative and then inflection points. So number line. Oh, by the way, is the derivative ever undefined? All right, that doesn't happen. It's a polynomial. So number line, 0, 2, -2, right? And I'm just going to open this. I want to see if we actually do get rain. There ain't no rain out there. All right, test points. Boom, 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 boom. All right, so anyone have any ideas here what's going to happen?
-3, -1, 1, 3.
So you understand what I've got to do now, right? -3. So I'm just going to, I think I'm just going to tell you what happens. Okay? So our function should go down here, then it should go up, then it should go down, and then it should go up. Right? I'm actually not plugging in the test points and going through that. You would have to do that, right? Yes.
You plug in your test points into the derivative.
The damn derivative, right? When you're trying to figure up and down, into the derivative.
And then concave is the original.
Nope, concave goes into the second derivative, yeah. Look at test points always go into derivatives,
Oh, the inflection goes into the original.
If the inflection would go to the original if you wanted to actually know where the point was on the graph, right? All right, we got this? We have local max at the point 0. Okay, so I have a maximum here, right? Goes up then down. So when I plug 0 into the original function, what do I get? 8. Hey, my y-intercept is a local maximum. Okay? Local minimum. I have 2 of them. I have one at -2, and I have one at +2. So I need to plug 2 and -2 into this. And won't I get the same answer? Because it's to the 4th and then squared. So let me plug in 2. What's 2 to the 4th? 16 minus 32, that's -16. -8, I believe we get here. Okay? Y'all still there? All right, I'm ready to move on to the second part of this, which is the second derivative. So my second derivative, I'm going to put right here. And that is, hopefully nice, 12x squared minus 16. Okay, I need to know where that's 0. So I set 12x squared minus 16 equal to 0. And I wish it were a little better, but it is what it is. What did you do? Do it?
Factor out of 4.
You want to factor 4 out? Can I just divide that 4 on both sides, get rid of it? How about we do this? Move the 4, divide by 3. Square root on both sides. We get 2 solutions, right? What are my 2 solutions? Plus or minus the square root of 4 over 3. I'm moving quickly. Negative root 4/3, positive root 4/3. Number line. Test points. 0. Okay, 4 divided by 3 is like 1 point something. Square root of 1 point something is 1 point something. I'm just going to go real safe. 10 and -10. I know those are outside of those, okay? And those are getting plugged into the second derivative. Okay, let's start with 0. Here's my second derivative right there. 0 in there. Negative. Concave down. 10 in there. Let's go 10 in here. Definitely positive, right? -10 in there. Still positive. Am I going too fast? I'm okay with this speed?
Is this how you want us to sketch it?
I'm not going to ask you to sketch anything, but I want you to see it, okay? Because this is how, I'm moving through this quickly because this is the way people that have calculus in their toolbox can sketch functions. This is the way it can be done. All right, so I have what? I know where it's going up, concave up, concave down, 2 inflection points, right? Okay. Everything that we've done